Good afternoon, everyone. I will endeavor to be brief. I don't want to keep you from your mid-afternoon coffee. It's an honor and privilege to speak to you here in honor and memory of Richard's legacy and human origins research. My history with Richard is perhaps slightly different than a lot of you. I did not meet him in the museum or in a conference. I actually went out to his house to help pick wine grapes so we could make some delicious wine. And we ended up having lunch on his beautiful terrace overlooking the Rift Valley. And I didn't know that this was becoming an unofficial job interview. And apparently my work ethic at picking grapes impressed him enough that a year later I was invited here to Stony Brook. Today I'm going to be sharing with you a new discovery from the Turkana Basin about the origins of Australopithecus. And this is on behalf of an international multidisciplinary team led by Louise and Meve Leakey, the Kubifora Research Project, and involving Carol Ward, Bill Kimball, who we also unfortunately lost last year. This will include geological work by Frank Brown, by his master student Casey Kidney, and paleontological and paleoecological work from Rhonda Quinn, John Rowan, Ignacio Lazagabastar, and Bill Sanders. As described earlier on Monday by Johannes, and if Sarai could have stayed, I'm sure he would have mentioned, Pliocene hominin diversity and the evolution of the genus Australopithecus are outstanding issues in paleoanthropology. Since the discovery and description of Australopithecus anamensis in 1995 by Meve and her team, and of course of Ardipithecus ramidus by Tim White in the late 90s and eventually the early 2000s, renewed attention has been paid to the timing and the macroevolutionary processes leading to the origins of Australopithecus. As represented in this figure from Tim in 2006, the then known fossil record could have been compatible with either an anagenetic origin of Australopithecus within a single evolving lineage from Ardipithecus, or a cladogenetic event off of it. Tim, of course, ends that paper with a plea for more funding, to do more fieldwork, to find more fossils to resolve that issue. I'll probably do the same thing. But thanks to similar continuing funding, but this time from National Geographic to the Kubifora Research Project, in 2011, Loki Saleh recovered a hominin mandible and associated fossils from Paleontological Collection Area 40, also called Ildora, in the northeast of Ilaret, near the border with Ethiopia. In this northeastern part of Area 40, we have strata belonging to the Lanyumun, the Moiti, the Lokachat, Tulubor, and some remnants of the Upper Burgi members from within the Kubifora Formation. The principal fossil locality lies within the Upper Lanyumun member, here, near the transition from predominantly lacustrine to dominantly fluvial strata. And in the region immediately surrounding the fossil site, several volcanic ash layers have been identified. The Guo, the Tukanan, the Kisime, which is dated to 4.06, the Kenyeris, the Moiti dated to 3.97, the Wargolo dated to 3.8, and the Beta Tulibor is always around, dated to around 3.42 million years ago. Extensive correlation work by Frank, by Patrick, who's here, and Casey Kidney in not only Area 40, but adjacent areas 14, 15, and 41 allow the placement of these fossiliferous layers into stratigraphic relationship with the dated materials and the overall paleomagnetic record for the column. The Guo, the Tukanan, and the Tulubor are all of normal magnetic polarity, whereas the Kisime is over here in red, and the, excuse me, there's so many tufts. The Kisime and the Canyeris are of reverse polarity. And within the Lanyumun member below the Guo tuff, it's reverse polarity all the way to the base, as is the fossil layer itself. So, the fossil layer must lie between the Nunivak and the Cochiti normal subcrons within the overall Gilbert reverse cron, which would be between 4.493, there we go, and 4.3 million years ago, right? So via the paleomag, and the superposed dated tufts, the site has to be between 4.493 and 4.3 million years old, but it's likely that they lie near the younger end of that range. In other lacustrine sections in the basin, deposition is very rapid, so that the 100 meters of sediment beneath the site might represent about 100,000 years, and with that estimate, it's most likely that the fossils date to between 4.3 and 4.39, and these fossils are in two layers, the mandible slightly above the other fossils, so an age closer to 4.3 is very conservative. The KMNER 63,000 specimen comprises two articulating fragments of heavily weathered and broken mandibular corpus with a broken right second molar crown and roots. And when Bill and I were examining the specimen in Nairobi, he used the anatomical term grotty. It's very, very eroded. Of the functionally heavily worn M2 crown, only the buccal enamel rim and the mesiolingual quadrant remains, but maximum buccolingual crown breadth can be estimated up here. Otherwise, the tooth row is represented only by badly eroded alveoli, and the two pieces join along a break that extends diagonally through the symphysial region, which we can see up here from below. So therefore, the exposed cross-section is not entirely mid-sagittal, but its contour can be reconstructed fairly precisely. The right fragment preserves very little of the cortical plate buccally and is weathered lingually, but the left corpus is better preserved, but it has been reduced by erosion by a few millimeters, unfortunately. And almost all of the alveolar margins are chipped away, making it a bit difficult to see the overall alveolar arch contour. But the heavily worn right second molar crown, the outline is almost square. It's hard to see here, but the mesial margin is a bit wider buccolingually than the distal one, and this tapering is common within the canopoi sample of Australopithecus anamensis. Our estimated maximum buccolingual breadth is around 14.5 millimeters, which falls within the canopoi anamensis. There we are, which falls within the canopoi anamensis and hadar afarensis ranges of variation, but well above the range for the Aramis and Gona samples of Ardipithecus ramidus. But unfortunately, the crown remnant preserves no useful occlusal morphology. The mandible is small, approximately the size of Lucy's jaw of afarensis, and is perhaps a bit larger in corpus depth as we move mesially. And the remnants of the central and lateral incisor alveoli, which we can see in the photo here and in the scan here, are unusually small. The apices of these alveoli extend inferiorly to less than half the total depth of the canine alveolus, which on the better preserved left side reaches nearly to the level of the mental foramen. In the anamensis type mandible from canopoi, the canine root is of similar length, but the incisor roots are almost of the same length. Right? So these incisor roots are strangely small. In occlusal view, the jaw has a pronounced V shape with strongly divergent post-canine rows. There we go. This differs from the more parallel-sided contours of the anamensis type specimen and other canopoi mandibles, and there are two possible interpretations of this difference. And the first would be that this is within the normal range of variation. This would be supported by the wide range of variation observed within the hadar sample of afarensis, ranging from the very V-shaped jaw of Lucy to the more expanded jaw of AL 400-1A. And there's even a small ramidus mandible from Gona that has been reconstructed as V-shaped. So maybe that all of these hominin species could have had anteriorly narrow, posteriorly divergent tooth rows. The other interpretation is that this specimen, 63,000, is abnormal. And this would be supported by the remnants of the incisor alveoli, which suggest unusually short roots and probably small teeth. These are unlikely to have been related to pre-mortem tooth loss, as we would expect to see some kind of alveolar resorption, which we do not. These inferred short roots do not by themselves unequivocally indicate some kind of malformation, but the poor preservation doesn't allow us to say very much more. The left and right canine alveoli of 63,000, and we see this one outlined here, are aligned with the reconstructed mesiodistal axis of the post-canine tooth row in red here. This reconstructed mesiodistal axis traverses the lingual third of the canine alveolus. In other words, this line ends here to the left of that circle. In Lucy's mandible of afarensis, with a similar narrowing of the dental arcade, the post-canine axis cuts across the buccal edge of the canine alveolus to the outside, to the right here, leaving the canine crown itself almost entirely medial to the post-canine axis. This medial shift to the corner of the dental arcade characterizes all Hadar afarensis, regardless of how convex or narrow the canine incisor arch is. And these observations suggest that perhaps the dental arcade shape and the placement of the canine vis-a-vis the post-canine axis vary independently of one another among early hominins. While it's impossible to reconstruct the exact angle of the symphysial cross-section in relation to either the alveolar or the basal margins, the superior half of the cross-section is approximately vertical up here, and then sweeps away posteriorly. This inclination doesn't appear to be as extreme in the other canopoi mandibles shown here, more like the one in the middle here. The external symphysial surface of 63,000 evinces a more convex or cut away surface here, such that it looks very pinched front to back, if you see that there. For comparison, the Hadar afarensis jaws, this is quite full, fleshed out front to back here, not pinched. And there's not as much posterior deviation sweeping back posteriorly here. In the afarensis hypodyme, only LH4 from Laetoli and a single Hadar specimen, AL 1496-1, out of over 24 mandibles, approach the anamensis condition. Basally, the strongly retreating anterior symphysial contour down here wraps around the corpus as far back as the mental foramen under P4. And this retreat places the basal margin medial to the buccal alveolar margin. This corner right here is what I'm talking about. Whereas in afarensis, it is over here. But enough of this complicated hominin morphological jargon. Let's move to the associated mammal fauna and the paleo environment. Taxonomically, it is quite diverse, although the sample sizes are quite small for most taxa, and suids are the most abundant family, which is true also at the nearby site of Mercy, and are represented by two tetraconodon species, Nyanzacurus pattersoni and Notochaerus jejuri. As Craig explained this morning, the pigs don't lie. Nyanzacurus pattersoni is a common Pliocene suid with elongated third molars in comparison to the more primitive Nyanzacurus species, but maintains relatively large third and fourth premolars and short bunodont post-canine dentition. Here. In contrast, Notochaerus jejuri has even more elongated and slightly more hypsodont third molars and reduced premolars that are intermediate in size. And here we can see the comparison of length and breadth clearly separate those two. The third molar of pattersoni is also wider and bulgier than jejuri, and the same pattern is clear here. Based on morphological, stable isotope, dental microwear evidence, pattersoni was likely a mixed feeder. On the other hand, jejuri is a very early part of the grazer lineage in the Pliopleistocene. These two are the only known suids from Canopoi, and the oldest securely dated fossils of jejuri are from Tabarin and the Turmeron Formation of the Tugan Hills at about 4.35 to 4 million years, and it's also at Mercy at 4. So that, with the absence of species from older than 4.35, like at Lothegum, like Notochaerus Nyanzaceros australis and Certicus indicate that this assemblage is likely to not be much older than 4.35 million years. Bovids are also present, and there are some nice horn cores. The bovid Trigelaphus chaloi is primarily restricted to the very earliest Pliocene sites in Turkana, and the record of Damalacra also fits with an age of older than 4 million. To reconstruct the paleoenvironment, looking at present-day sub-Saharan African mammal communities shows that mean hypsodony, or height of the crown of a tooth, is a strong predictor of mean annual precipitation. And the estimated precipitation for the Area 40 fauna is around 713 millimeters here a year. And this is in line with other values from Kenyan Anamensis. Those are slightly higher. And Asaisi and Aramis in the Middle Awash seem to have been wetter, whereas Hadar and Mercy were a bit drier. But these intervals are extremely wide, so it seems sensible that maybe we think of all of them as equivalent, but if you want to stretch, you could say maybe there's some directionality that is a true ecological signal. Sampling also is an issue, so Area 40 and Mercy also have the lowest sample sizes. That's a confounding factor. But this range of mean annual precipitation from these Pliocene sites overlaps with the range of present-day savanna chimpanzees from Senegal and Tanzania, demonstrated up here, and a rainfall range of about 700 to 1050 would result in a mixed woodland to savanna or forest-savanna mosaic environment, although we know fire is going to be playing a role in the vegetation regime as well. So this suggests that, like living savanna chimpanzees, Ardipithecus ramidus and Australopithecus anamensis were probably specializing in C3 foods despite living in an environment with abundant C4 resources, but Afarensis is exploiting more of those C4 resources within broadly similar environments. Additionally, we use bovid abundance data as a paleoenvironmental measure that's less sensitive to sampling, and these also suggest important shifts through time. Bovid taxa that rely on more woody environments, like the Trigelaphines, Apiceratines, or Impalas, make up as much of 62 to 95% of the sample from Ramidus and Anamensis sites, but drop to 34 to 40% at Hadar. Additionally, we have faunal tooth enamel delta carbon 13 isotope values. These indicate that the environment was dominated by C3, C4 mixed feeders, similar to at Canopoi and at Mercy, but we have slightly more grazing taxa than either of those. When we compare values by taxonomic group and by area, between Area 40, Canopoi, and Mercy, very few show any significant differences. The Area 40 faunal tooth enamel delta oxygen 18 isotope values by taxonomic group demonstrate wide variance, and we heard about these issues with Kevin before, so this could be related to water dependency and other mechanisms, and when we try to gauge that across sites, Anamensis appears to have been living in mixed habitats with a limited spatial scale, and these differences between sites in delta oxygen could be related to different, again, drinking, food values, and also source differences like the Proto-Cario River coming from a different source through Canopoi versus the Proto-Illiret or Omo River coming through Area 40. So generally, at this time, the Omo-Turkana Basin appears to have been dominated by C3, C4 mixed feeders. Browsers and grazers were also present. And we seem to be sampling a woodland environment similar to those that we're familiar with today in which savanna chimpanzees live. But as we heard from Kay and others, the non-analog nature of Plio-Pleistocene Eastern Africa confounds detailed comparisons between the past and the present, and additional proxy data will be needed. Kevin, I will be talking to you later. In summary, despite extensive damage, KNMER 63,000, preserves sufficient diagnostic anatomy in the anterior mandibular corpus, the dental arcade geometry, to warrant its assignment to Australopithecus anamensis. Of particular importance are the alignment of the canine alveolus and the post-canine dental row axis, and the strongly inclined symphysial axis with a basally convex sweep here, cutaway external surface, and inferior medially sweeping lateral corpus. In these features, it is easily distinguished from afarensis. Whatever the cause, though, the extremely narrow anterior dentition of the dental arcade does not obscure the diagnostic anterior and lateral corpus features that align the specimen with anamensis and differentiate it from afarensis. These features are demonstrably primitive retentions. Temporally and morphologically, 63,000 precedes the apparent shift towards a more vertical symphysis in hominins that appears to begin with afarensis, and although some of these primitive mandibular features may also apply to Ardipithecus ramidus, the thick mandibular corpus and the large M2 crown precludes this fossil being attributed to Ardipithecus. With an age of at least 4.3 million, 63,000 is the oldest currently known specimen of the genus Australopithecus, predating the Canopoi and Osaisi anamensis samples by at least 100,000 years. This specimen extends the known temporal range of anamensis to within penicontemporaneity with the latest documented occurrence of Ardipithecus ramidus at 4.3 million at Gona in Ethiopia, and that's without mentioning the Bertelli foot at Ronsomelia at 3.4 that Johannes discussed on Monday. Evidence from 63,000, like its mandibular corpus thickness and molar size, indicate that this reconfigured mascatory system, which differentiates the basal hominins from the earliest Australopiths, existed in the very narrow temporal window, if any, that would separate the two. Now, while not definitive on this issue, we think the very close temporal juxtaposition of these grade level differences counts against the hypothesis that Ardipithecus ramidus and Australopithecus formed a single anagenetically evolving lineage, and this is in agreement with what was already proposed a few years ago by Andrew Dew, Bernard, Zerai, and others based on statistical analyses of the dating uncertainties of the then known fossils at the time. So as always, continued fossil discoveries in this new great age of discovery into our origins, and of course inspired by Richard and his legacy, will be needed to further clarify this issue. Thank you very much for your attention.